Hi everyone, in this video I'll show you how to determine if a triangle that's plotted in the coordinate system is a right triangle. Now if we know the side lengths of a triangle, we can determine if it is a right triangle by using the Pythagorean theorem. A squared plus b squared equals c squared. And if it turns out that this equation is true, then you have a right triangle. But we don't know the side lengths yet. To determine those, we'll use the distance formula. So that is distance equals, and actually I like to set it up like this. So it'll be the difference in the x coordinates squared plus the difference in the y coordinates squared, and then the square root of all that. Now that seems complicated to look at, but in reality it's just another flavor of the Pythagorean theorem itself, and I'll show you that at the very end if you want to stay around for that. But if you just want to know how to do this problem, here we go. So let's find the length of AC first. So AC is going to equal the square root of, all right, so we've got 4 minus 7 for our x coordinates, quantity squared, plus 2 minus 4, quantity squared for the y coordinates. And that is going to equal -3 squared plus -2 squared, which equals 9 plus 4, and that is 13. And of course, all that's under the square root symbol. I'm just skipping over saying that each time. All right, and then AB, same setup. So AB here, so we've got 4 minus 3 quantity squared plus 2 minus 10 quantity squared, which gives us 1 squared plus -8 squared. And then that's 1, and then that's 64. So we've got 65 there under the square root sign. And then the third length we need to find is BC. So BC right there. So we've got 3 minus 7 squared plus 10 minus 4 quantity squared, I should say quantity. And that gives us -4 squared plus 6 squared, which is, that'll be 16 plus 36. And that's 52, all under the square root sign. So now we've got these three lengths, and I can actually label that on the diagram. So here we have square root of 13. Here we have square root of 65, which is AB. And then BC, that's square root of 52. Notice I'm leaving these as radicals. I'm not going to the calculator and getting a decimal approximation. I don't have any perfect squares here, but that's not going to be a problem because we're going to square all those things when we put that into the Pythagorean theorem. So we'll plug the lengths we have into the Pythagorean theorem, and we know the longest side will be C, so we'll put that over there by itself. That'll be square root of 65 squared. And then over here, A and B, doesn't really matter what we call them, we just need the two shorter sides. So that'll be square root of 13 squared plus square root of 52 squared. And what we're really saying is, actually, does it equal 65? Now, when we square each of these quantities, well, squaring the square root of something just gives us whatever was inside. So that's 13, that's 52. And we're saying, does that equal 65? And, well, we can just do the addition right over here, 52 plus 13. Yep, it equals 65. True. So that means that triangle ABC is, in fact, a right triangle. And the right angle is right there. So that's how to do that kind of problem to determine, is this a right triangle? You use the distance formula and the Pythagorean theorem to get your answer. So as promised, here's just a little extra bit about why this distance formula is actually the Pythagorean theorem. It's just in a different appearance. So if we look at this triangle and say, well, gee, you know, I could actually find this length if I made a right triangle right over here. And then I can just count, like this side is 1, 2, 3, 4, 5, 6 units, and this side is 1, 2, 3, 4 units. And then I could determine, well, that's, you know, going to be 4 squared plus 6 squared equals, you know, let's call this e squared. Well, that's 16 plus 36 equals e squared, which is 52 equals e squared. And then e would be the square root of 52. But look, that's exactly what we got over here. And then let's say we look at this side, or this AC units here. So we've got 1, 2, 3 units along here and 2 units along here. Well, that would be 3 squared plus 2 squared, and we'll call this f, equals f squared. So that's 9 plus 4 equals f squared. So f squared equals 13. And if we take the square root of that, well, that's what we have right here for this AC. And then similarly over here, we have, this is a very skinny triangle. We have 1 unit here. Actually, let me write that in a color we can see. We have 1 unit here, and then we have 1, 2, 3, 4, 5, 6, 7, 8 units here. Well, that'll be 1 squared plus 8 squared. Let's call this g equals g squared. So 1 plus 64 equals g squared, and g squared equals 65. And then that's what we have right over here. You know, so if we took, you know, the square root of both sides, we'd get g equals the square root of 65. Up here, we'd have e equals the square root of 52. And over here, we'd have, you know, f equals the square root of 13. And that is what we got all the way through here. If you have any questions, any problems you'd like to see worked out on this channel, just please leave me a note in the comments. Thanks for watching.